Hi, I'm Antonis. I'm from Q Technologies, and our mission is to involve households and small businesses in the energy transition.
Demand-side flexibility for the world's millions of small buildings has the potential to have a massive impact on the energy transition. Antonis, what technology is going to be the major driver to make these buildings more flexible?
It's a very good question. Demand-side flexibility from small buildings has to rely on a massive amount of data, especially if done automatically. Right? Engaging these millions of homes in the energy transition requires some automation. For that, you need data. Right? So this data has to come from Internet of Things solutions where you capture the data locally. Then you need tools and technologies like digital twins, for example, machine learning techniques, artificial intelligence, which helps you understand what's going on in the household, how is energy used by the people, how the appliances use the energy, and create basically a virtual replica of the building that then you can remotely monitor and understand energy patterns within that building. Knowing this, you can also understand how you can shift the consumption of appliances either in time or in power, for example, right? You understand how people use the appliances, and then you can understand what's the impact of this usage on the building per se, indoor conditions and so on, and then you can also understand how to shift this demand in time, rather. And this is what flexibility is all about.
Okay, so how is all this technology going to be an enabler for communities to actually save on their energy bills?
Yeah. So demand flexibility is, as you said, an enabler for several different applications that are relevant for communities. One would be cost savings, right? Everybody wants to save on costs. So assuming that they are in a dynamic tariff scheme, right, or they have a time of use tariff, they have times of cheaper electricity and times of more expensive electricity within the day. So you can shift consumption of some appliances, right, some energy-hungry appliances in the home to times of cheaper electricity. The net effect is that, or rather the end effect is that you have a lower electricity bill, but there are more applications of flexibility. You can go to markets, right? There are demand response markets, even balancing and so on. Also, there are communities which deal with or have collective self-consumption schemes. So they have their own production and they want to basically maximize the consumption that's done simultaneously with the generation patterns. So you can use flexibility basically to match generation and consumption. And this results in a benefit for the members of the community, basically because they're not exposed to market prices for electricity, right? They have their own production means, stable costs, stable price, right? And they can save on their bills.
You mentioned data earlier. Getting all that data and then using it properly presents some challenges.
At the moment, what we're dealing with is trying to make a business case / business model working out the techno-economics, right? The technology is there to get all this data out, but obviously technology costs, right? You need sensors, you need all kinds of components to measure what you need, to actuate on components and on appliances and so on. So you have to make the techno-economic work, and we have to put this in the perspective of not all the consumption of a household can be made flexible. There are limitations, right? You can play with some appliances, but with some you have no flexibility. So right now we are investigating for which end applications, like for example, net metering or net billing, demand response, and so on, for which application the techno-economics could work either today or in the short-term future. And that's where we want to focus to roll out, basically to develop and roll out a service in the short to mid-term.
So this is specifically for small buildings. How do the solutions for small buildings and small to medium enterprises differ from large-scale buildings?
The reality is that large buildings typically already have what they call building management systems, BMSs. So they are already very well instrumented with all these measuring points and so on. The data is being collected into data collectors. So in principle, it's available. And in that sense, it's an easier case, and it's one that's already partly addressed by the big market players. So this market is, if you like, already partly captured by the big players. but also the entry barriers for them are much lower. For us as an innovative SME, we have to look at our own niche, which is the one that is harder for them to actually go in and engage.
Antonis, this has been a fascinating discussion. Antonis will be at Enlit Europe in Paris in November. If you want to talk to him or any of the other fabulous members of our community, we'll see you there.